In this first exercise, we want to determine where the function is evaluated. And so we are given a function, f of x, 4x squared minus 3x plus 1. It doesn't really matter. I don't care what the function is. But this notation down here, f of 0 is how we say that, means anywhere you see an x, plug in 0, or whatever's in the parentheses. So for part B, wherever you see an x, plug in minus x. So I'll show you how that goes. So the first one, part A, looks like this. It would be 4 times 0 squared minus 3 times 0 plus 1. Notice I've plugged in 0 everywhere I see an x. I know that anything times 0 is just 0, so this winds up being equal to 1 in the end. Similarly, for negative x, we're going to plug it in wherever we see an x, so it would be 4. Make sure you utilize your parentheses here. It's important. Minus 3 times minus x, great, plus 1. Well, anything squared is just positive, and so you get 4x squared again, but now two negatives make a positive, so plus 3x plus 1. So that's the final answer for part B. Now we want to evaluate for A. But again, whatever's in the parentheses, you plug in for x. So it would be 4a squared minus 3a plus 1. Simple as that. Now, a little more complicated, but it looks a little more complicated, but it's the same idea. Plug in whatever's here for x. So what does that mean? Well, I'm going to put an x plus h everywhere I see an x. So that means I'll have 4x plus h squared minus 3x plus h plus 1. And normally we want to simplify this out, and so if we simplify this using our standard two binomials, then we would just get 4x squared plus you have 2xh, so it would be 8xh, and plus 4h squared minus 3x, now distributing up here, minus 3h plus 1. And that would be the final answer for this here. This really comes into play for the difference quotient, very important. Now we have one more exercise for this one. This is kind of a prerequisite for calculus, just a little short video here, but you're really going to know how to do this college algebra, algebra 2 type of thing. So we just want to determine where this function f of x is increasing or decreasing. F of x depends on x. Well, when it's increasing, the slope is positive, or it's going up. Notice the slope is 0 and negative 2 and 3. But the function is getting larger as we move to the right in the x direction. It's going up. So we know that we can say that it is increasing from negative infinity. Well, then when does it stop increasing? Negative 2. And then you may want to use your interval notation here. They usually specify, but interval notation means where else is it increasing? The union of these intervals. Well, I know it's decreasing from negative 2 to 3, so we can actually just write that down right now. Why is it decreasing? Well, it's going down. The function is literally decreasing as I move forward in x. As x gets larger, goes to the right, it gets bigger, this function is decreasing in value. Look, it's whatever it is there, maybe 5, but it's above the x-axis, and then it's below the x-axis here. That means that it's decreasing. And then at 3, the slope is 0 again, but then it increases until infinity. So it'd be 3, infinity. Simple as that, and that's all we have for this one.